Hi, this is a video of the first amp I built in 2006 using MRF 150 Mosfets, solid state rig designed by Motorola engineer Helge Grandberg, who was also a ham, now long since a silent key. I've upgraded the amp over the 14 years that I've owned it to its present state using new transistors that are capable of powering up to a kilowatt and installing a water cooling system that has worked very, very well. When I turn it on, you'll notice under the 842, those are the bands I typically use, and they represent the low-pass filters respectively for those bands, and a little LED light below them indicates which one's active. Upper left-hand corner is a digital readout of the temperature module on the copper spreader to indicate or to monitor the effectiveness of the water cooling system, which is using distilled water. Also, the amp has a built-in -7 dB attenuation pad in front of the transistor gates to protect them from overdrive, which is a typical cause for transistor failures with high-gain devices like Mosfets. I've got it paired up to ICOM 7300 set for 18% out, which equates to about 18 watts, but through the -7 dB pad cuts it down to about 3.5 watts that land on the gates. So I'm going to turn it on. You can notice the slow start module bringing the voltage up in sequence. So here we go. And the temperature is showing 17.6 degrees Celsius, probably an indication of the ambient temperature in the room. And I'm going to check, make sure we're not going to be bothering anybody on a clear frequency. And we'll do a little test transmission. Bear with me here. It looks clear. When I key the amp, you'll see a little current draw, which indicates the bias is turned on the transistors. Usually set for about 200 milliamps. So you could see that come up there. So this is W6KAN checking the frequency. QRZ. So nothing heard, and we can see, I'll turn down the volume here. So W6KAN going QRT. Anyway, you notice the amperage comes up to about 13, 14 on peaks, and that would calculate out at about 500 watts output. We'll take a quick look at the inside and then at the water cooling module. I may need a little help because it's a little dark here in the shack with a flashlight. We're looking at the toroidal transformer running on 120 volt primary, about a 39 volt secondary, going to rectifier module, feeding 5 electrolytic capacitors with a total of 125,000 microfarads. And in the back here, well, here's the soft start module. Using a hockey puck relay and a little transistor circuit. And then a low voltage transformer which powers the relay and the bias. It's a triple pole, triple throw relay, the low pass filter module, and then back here I'll highlight this so you can see the copper tubing soldered on to the back of the copper spreader. This is the input line with distilled water, and this is the output line. And the temperature probe is tied to it. So we're really monitoring the output water temperature, which pretty well corresponds with the temperature of the copper spreader. And then on the back side, probably can't see it, but the transistors, the output transformer, input transformer, and the bias control. And we'll walk into the adjoining room, which is a kind of a junky parts room, and we'll take a look. This is a 9-inch aluminum radiator used by gamers to cool their CPUs. I've got 2 muffin fans running on it. The water comes in from the amp, goes through the radiator, drops into a reservoir above a 12-volt pump. So it goes round and round, and basically never seen the temperature rise above 38 degrees Celsius. So it keeps the CPU very cool under continuous load. So if you have any questions, you can email me, W6KAN @arrl.net. Thank you.